All right, welcome to video number 2 for week 11. We're going to be talking specifically about kites and trapezoids during this video. So let's jump right in. I'm going to be basing this on the order that it's in Springboard, but we won't be really using the textbook at all. So we have kites. Let's go back and remind ourselves about what a kite is. So we wrote down on our Freyr model from the last video, a kite is a quadrilateral with two pairs of congruent consecutive sides. We have additional things about it, but let's talk about some words first. So let me draw a kite. Trying to make sure it looks like a weird kite. So we have G, E, O, and M. We have this shape. So we have sides that are opposite from each other. All right, GE and MO are opposite because they don't touch. Right, they're cross. That also means GM and EO are also opposite. The other vocab word for sides is consecutive, which we already used in our definition of our kite, and it looks like I spelt it wrong. Consecutive. Consecutive sides, those are the ones that touch. So we have GE is consecutive, right, with EO. GE is also consecutive with GM. All right, MO is consecutive with EO, and MO is consecutive with GM. So there's 4 pairs of consecutive sides. Now let's move on to angles. We have opposite angles. Same thing, just means that they're across from each other. They're the ones that don't touch. So angle G and angle O, and then we have angle E and angle M. Those are opposite, they don't touch. And then we have consecutive angles, and those are the ones that are next to each other. That would be angle G and angle E and angle O and angle M and angle M and angle G. Those angles are next to each other. The last thing that we're going to talk about real fast is diagonals. And these are those lines where we connect opposite angles. So we said GO are both opposite angles. So that means line segment GO is a diagonal. We can also say ME is a diagonal. They have 2 diagonals. Quadrilaterals will always have 2 diagonals, and we're going to learn properties about their diagonals. Sometimes they will be drawn, sometimes they will not be. So that's the intro to the vocab. Now let's go in and learn some properties about our kites, and we'll go back and talk about them. So we should be adding these to our Freyr models as well. The first property is diagonals are perpendicular, which means they meet at a right angle. All right. A second property would be there's one pair of congruent opposite angles. All right, I'm narrowing it down from the ones that we did from last year. And then the last one is one diagonal is bisected by the other. So let's take a look back at our kite, and then let's look at this. So if I had drawn this correctly, our two diagonals would be perpendicular, right? One of these diagonals gets bisected, and then there are two angles here that are congruent. G and O definitely aren't congruent, but M and E are. So let's look at another example, and I'll try to draw this one more carefully. Okay, so here's another more carefully drawn kite. Let's call this one Macy. So let's draw those diagonals. We have this diagonal connecting I and A, and then this diagonal connecting M and C. So here we can see very clearly that the diagonals would be perpendicular. Next, we have to think to ourselves, number one, this is a kite, so we know there are two pairs of consecutive congruent sides. And then we also know, because of our new properties, there are two angles here that are opposite that are also congruent. So we have to look at this. There is a way to figure this out. It's the angles that are between not congruent sides, but non-congruent sides. That means I is in between the longer and shorter side, and A is the same thing. Those match, and it's also that diagonal that gets bisected. So on Khan Academy, you might run into the problem where they give you a kite. They tell you it's a kite. They say this angle is 30 degrees, and you have to figure out how big that angle is. There's no arithmetic to do. It's just using the property that the angles that are opposite from each other in between the two non-congruent sides are equal. So x would be 30. This is the shape with the least amount of properties that we can then write formulas for. We'll see a lot more examples later on. But that is pretty much with kites. I could also say, if this is 40 inches, what other side is 40 inches, and it have to be the one with the mark on it, right? There's not too many things we can do with kites. Far more interesting shape that we're going to have in this video is our trapezoid, all right? With trapezoids, we have exactly one pair of parallel sides. And they have to be opposite, otherwise there's no way for them to be parallel. So let me draw a regular trapezoid, which means even though the sides are parallel, there's nothing here that's congruent. So in this situation, we have a couple of properties that come up because of the parallel sides. If we draw the diagonals, there's nothing really anything fancy here. So the diagonals, the trapezoids, we really don't do anything with, so I'm going to actually get rid of that. Instead, because of these parallel sides, we have two U's, right? And we remember from our previous units that those U's, we would call them same side interior angles, and they are supplementary. So if we label this A, B, C, D, we can say angle A and angle D are supplementary. That would also be true on the other side, right? Here's another U formed in between two parallel lines. So angle B and angle C are supplementary. That is our first property, and we'll go back to our Freyer models and write that. We also have a similar property than we did with our triangle. So if we make a specific line that we connect to midpoints, there's something nice about this line, but we need some more vocab words before we continue. So on any trapezoids, we have two bases, right? A base is the side. Sorry, bases are the sides that are parallel. Legs are the sides that are not parallel. All right, so what we are going to construct this line, all right, is just like our mid-segment of a triangle, but unfortunately, in a trapezoid, it's called the median, just like the median of a road, middle, right? So the median of a trapezoid has a very similar formula. All right, the median is equal to 1/2, but because there's two bases here, we have to do base 1 plus base 2. With our triangle, it only has one base, so we only do one base. Trapezoid, we have two bases, so we have to add them up. We can, and probably on our paper, not put that, just do base plus base. So let's actually add that to our Fourier models. We have property 1, which says angles on the same leg are supplementary. And number 2 says the median is equal to 1/2 base plus base. So let's actually try to use this formula with some numbers, before we go into our next part of it. So let's look at trapezoid, TRAP. So if we draw that median, we have some different types of problems that might pop up. First one, let's just do it with some numbers. So let's say this is 16 and this is 24. We want to figure out how big the median is. So when we do this, we have to remember our rules, and our rules say our median, our x is equal to 1/2 base plus base. So that would be 1/2 of 16 plus 24. So x is equal to 1/2 of 40. So x is equal to 20. So that means our median here is 20 units long. We might have a more interesting scenario where we have, instead of numbers, we have some variables. So here we have our median, but now we have a little bit more complicated situation. So let's set this up. We do median is equal to 1/2 base plus base, and it might help if you label it, right? We have the top base, we have the bottom base, and we have the median. So we can plug it in. We have 3x plus 10 is equal to 1/2 the first base plus the second base. And then we just do our math, combine like terms. We have 3x, but then 16 plus 19 would be 35. And just like with the triangles, instead of distributing the 1/2, I'm going to multiply both sides by 2 and then distribute the 2. Combine like terms. So we get 3x is equal to 15, divide by 3, so x is equal to 5. We're not done yet though. Let's figure out how long each part is, which means we're plugging it back in. So we do 3 times 5 plus 10, so 15 plus 10, so 25. And then down here we have 3 times 5 plus 19. So 15 plus 19, so that's 34. Right, we can check our work. The median is in between, and if we add these up, we would get exactly 25 as our median. So that's how it can get complicated. We have a couple of other examples here. So let's now look at one more before we talk about isosceles trapezoids. So the last type of situation, we have a trapezoid, and I give you these two angles on the sides. So we only have two properties, right? We don't see the line drawn, so it can't be about that one. It has to be the other property, which says the angles on the same leg are supplementary. So right here we have the bases, here we have the legs. So now we have the situation where the angles on the same leg are supplementary. So we can add these two together and set it equal to 180 because that's what supplementary means. And that's because we have the two parallel lines and they form that U. So we combine like terms. We have 16x minus 12 equals 180. We combine like terms by adding 12 on both sides, get 192, divide by 16, so we get x is equal to 12. We then want to actually figure out these angles, so we plug them in. 24 plus 12 times 12. So up here, that would be negative 24 plus 144. So we get, is that 120? And then down here, we have 4 times 12 plus 12. We have 48 plus 12. So we get 60. So we have two angles that do add up to 180, so we know we're good. But you might also get a situation where we know we have a trapezoid, and now both the legs are congruent. And that means we're going to call it an isosceles trapezoid. The legs are the same. And the situation that we're going to have is something like this, where I give you this corner down here on the left and then the corner up here on the right. We can't use what we learned. So we actually have more properties if our trapezoid is isosceles. So if it's isosceles, we can say the angles on the same base are congruent, and we can say that the diagonals are also congruent. And again, that stems back to using triangles. We're not going to really talk about the proofs, we're just going to practice it. So here, so that means if this is isosceles, because those two legs are the same, that means this is also 14x minus 5, and this one over here is also 25x minus 10. So now we have all four angles, and we have to use the fact that we have the angles on the same leg. So we have 25x minus 10, and we're doing it just on one leg, doesn't matter which one, because they're identical. 25x minus 10 plus 14x minus 5. Those are supplementary, so it's 180. So even though we kind of have different scenarios here, we're still using the second property that these angles are supplementary. We'll just also using the added thing about isosceles trapezoids where the angles on the same base are also congruent. So minus 15 equals 180. We add the 15 to both sides to get 39x equals 195. We divide by 39 to get x is equal to 5. And we have to plug it back in. So we do 25 times 5 minus 10, so it's 125 minus 10, so that's 115 degrees. Down here we have 14 times 5 minus 5 So we have 70 minus 5, so we have 65. And we can check our work by adding those together to see if we get 180, and we do, which means this angle is also 115 and this angle is also 65. So that's how we would find the missing angles in a trapezoid. Okay. And then the last type of problem you'll see about trapezoids would be using that last property that says if our trapezoid is isosceles, let me draw it different. If it's isosceles, which you can always make a bad drawing look good by adding our markings. So this is an isosceles trapezoid. If we have the two diagonals, so let's say this is DEFC. If our two diagonals, DF is equal to x plus 12 and CE is equal to 4x minus 9, we can actually figure out what our diagonals are. So let's draw those. CE is this diagonal right here, and that's 4x minus 9. DF is right here, and then that's equal to x plus 12. Because this is an isosceles trapezoid, it means that the diagonals are congruent. We like the word congruent because that just means they're equal to each other. So we do x plus 12 is equal to 4x minus 9. So again, now that we have the equation set up, we just use what we know from algebra to solve for x. We can subtract x on both sides to get 12 is equal to 3x minus 9. Add 9 on both sides to get 21 is equal to 3x. Divide by 3 on both sides to get x is equal to 7. And then once we're done, we can plug it back in. So here we get 19. We don't even have to worry about it. Over here, we'll also get 19 because they have to be the same. So to review, we talked about kites and trapezoids. Kites are where you have two pairs of congruent consecutive sides. Then we have three properties. In all kites, the diagonals, right, are perpendicular. We also said that the one pair of opposite sides are congruent, and it's always the pair in between the non-congruent sides. And we also said when diagonal gets bisected, which is that same part of the kite on those opposite angles that are congruent. In a trapezoid, we talked about regular trapezoids and isosceles trapezoids. In all trapezoids, the angles on the same leg are supplementary, right? So in this example down here, A and B would add up to 180. The median would be 1/2 of the base plus base. So here's the median. So this is 10 and this is 20. That means the median would have to be 15 because it's half of 10 plus 20, which is half of 30. In a isosceles trapezoid, that means the legs are congruent. We have two more pieces of information that's true for only isosceles trapezoids. Not all trapezoids, only isosceles trapezoids. And that's the angles on the same base are congruent. So here, these two would be congruent, and these two would be congruent. And then the diagonals are also congruent. So that's all the information about kites and trapezoids that we'll be learning. You'll be practicing those on Khan Academy, and a short worksheet for the ones that I could not find anything on Khan Academy for. Good luck.